Hello and welcome back for part 2 of the DC-DC converter. In this video, we're going to be going deeper into some serious components. You guys are going to learn a lot, so let's go ahead and get started. We're going to be starting off with these fuses right here. But these are really unique because inside these fuses is some sand. And I'm pretty sure you guys haven't seen a fuse like this because typically they look like this, right? And the reason why they have sand is because they're working with high voltage. And if these were to blow, what happens is that the arc is going to be restrained because of the sand. And not only that, if it blows and we're dealing with high voltage, the sand prevents it from shattering as well. But I thought I'd let you guys see that. And this is a high voltage fuse with sand in it. Now it could be sand or silica, but this is really neat. So I took this off. I had two 8mm bolts, but I wanted you guys to see this. We have two of them. Now on the topic of fuses, we have this bad boy. So this fuse right here is a high voltage fuse, and it is encased in copper. And the reason why they're using copper is because copper has low resistance, so it's great for conductivity. And the case is copper, but inside it also has the same type of design as the smaller fuse, where usually there's some sand or silica in there. And again, it's preventing it from having a major arc and expanding and damaging anything else. But this is a EV automotive fuse typically found in these junction boxes. Now, I want you guys to know that a junction box in an EV car is typical. This is a common system found on EV systems. A good example is that the Honda CR-V is almost identical, and other cars, other EV cars have similar junction boxes. And this is a Japanese part. This company actually produces about 70% of all high voltage fuses, which is really cool. And I think it's the same company for this one. We're going to be talking about this resistor right here. Now this resistor is ceramic, and inside the resistor is going to be the windings, usually metal. And what this resistor does is that it prevents the capacitors to be charged too quickly, because that could be an issue. And it's made out of ceramic to prevent heat, to help heat dissipation, and these are usually used for high voltage systems. Now let's look at our Panasonic relays. I'm calling them relays, but these are switches, and their job is to switch the system on and off. They're used for safety. They're used to isolate the system in case of an issue. Let's say there's an accident or something happens. These are going to switch the system on and off, which is great. They can also be used for different things, but now you know what they are, and these are going to be very common in EV systems. But you guys now know about the fuses, the sand, the relays, the connectors, and the resistors. In the next video, we're going to be talking about the converter, and I'm going to see if I could take off this housing so we could see the actual internals of the converter. But this is where the DC to DC conversion happens. This is where they're reducing the voltage from high voltage to low voltage so they can use it with the regular 12-volt battery, your typical battery out there. But again, this converter produces a lot of heat, and somebody did make a comment in our video when we posted it on the Facebook page, and they talked about EV systems and their heat. And we wanted to let you know, guys, it is all about heat. You saw the duct in there, right? You also saw that high voltage fuses, they are literally designed to prevent damage due to heat and high arcs. And a lot of high voltage stuff is literally designed to protect the system and protect the car and the user itself. So hopefully you learned something more about the junction box, again, which is typical in all EV boxes. They might be configured differently, but now you know a little bit more about it. And in our last video for this particular part, we're going to connect everything. We're going to wrap everything up and show you how it all works together, because you will understand the parts, the terminology, what they're doing. And so when we explain how everything turns on and kicks on and works, you will know. All right, guys, make sure you hit that like button. We appreciate it. Leave any comments in the description. You guys take care and stay tuned for the next video.